Alright guys, hello and welcome to today's lesson. This is Mr. Ludden and today we're going to have a look at exam questions involving finding the roots of a polynomial. As always, any of the key points that I make throughout this video will be in the description below, and I'll also put a comment in the comment section with a timestamp of each of the bits of content that I go through so it's easier for you to find. As with the whole Leaving Cert Maths course, it's built upon what you know from Junior Cert, and these questions here especially are no different. So in order to factorize a cubic polynomial here, we need to have a good understanding of everything on the left hand side here. So your factors, your roots, quadratic equations, your minus b formula, your division, and your substitution. And once we have an idea of those 6 things on the left hand side, it'll make our exam questions a whole lot easier. So I'm going to take the main points from the words on the left hand side there, and we're going to build ourselves up so that we're in a position to answer a Leaving Cert higher level exam question in a couple of minutes time. I have done some videos for my Junior Cert higher level classes on a lot of these things already, and I will put a link to those in the description below as well, just in case you feel you need a bit more background info. So we'll start with polynomials. What actually is a polynomial? A polynomial is an expression or an equation with many terms, and you're usually dealing with the same variable but different powers of that variable. So just to highlight what I mean there, if we look at our cubic expression here, you'll notice that we're dealing with x cubed, x squared, x, and if we wanted to give x there its full name, that's the same thing as saying x to the power of 1. And then you've got your d at the end there. And you could put in, if you wanted to, this is like a recap on your indices. That's the same thing as d multiplied by x to the power of 0. Because as we know from our indices, x to the power of 0 is just 1. So that's the same thing as saying d multiplied by 1, which is the same thing as d. So that's just getting across the point that a polynomial is an expression or an equation where you're dealing with usually with the same variable, but from each term to term it has different powers. For your Leaving Cert, you need to be able to distinguish just by looking at those equations whether they are linear, quadratic, and cubic. And you can tell that fairly easily by the highest power of x in that equation. So we'll start off with our cubic, and if we look at all our x's, so x to the power of 3, x to the power of 2, x to the power of 1, and then the x to the power of 0 that I was talking about a couple of seconds ago, the highest power of x is x to the power of 3. So by definition, this whole thing here is going to be a cubic expression, or equation even. It has an equal sign here. If it has an equal sign, it is an equation. If it doesn't have an equal sign in it, it is an expression. For a quadratic, and you will be familiar with those from your Junior Cert, the highest power of x is going to be a 2. And for your linear equations, the highest power of x is going to be just x on its own, or if you wanted to keep talking about the powers there, like we did with our other 2, this would be x to the power of 1. Those 3 equations in front of you are the general form of a linear equation, a quadratic equation, and a cubic equation even. And the a, b, c, and d in these equations, they just represent any number that you can think of. For the questions that we'll be having a look at in a couple of minutes time, we'll just be dealing with integers for the letters a, b, c, and d there. So for example, if you had something like 2x squared plus 7x plus 13 is equal to 0. First of all, you could say that that's a quadratic because the highest power of x is 2. And in this scenario here, I'll just get rid of my red lines here just so you can see what I'm talking about. The a here represents the 2 because it is the coefficient of the x squared. So coefficient means the number before. Your b here would be your plus 7, as the plus 7 is the coefficient of x. And your c doesn't have an x attached to it at all. And the same thing is true of the 13, the plus 13 at the end of my example here. So in this situation, your c would be positive 13. So this is what a quadratic looks like, but in your questions, you'll be given ones usually with numbers before the x squared, the x, and a number at the end. Same thing for your linear and your cubic equations. Just moving on from that and sort of a step up, if we were to look at what a linear equation, a quadratic equation, and a cubic equation looks like as a graph, we can take information from what we know here, here, and here in order to have a rough idea of what the graph will look like before we go substituting anything in or looking for points in that graph or anything like that. And the key to knowing about the shape of the graph lies with the sign of the a here. So whether that number is positive or negative. In a linear equation, if the a is positive, your graph is going to be a straight line and it's going to go upwards from left to right. If a is negative, it's going to be a negative slope and it's going to go downwards from left to right. You would have seen this in your coordinate geometry with the equation y is equal to mx plus c. So if you'd noticed that, well done. Moving up to your quadratics, if the a is positive, the way I teach my classes is if the a is positive, that's a good thing. So if it's a good thing, we're going to have a smiley face. So your graph is going to be a curve and it's going to make a smile. If the a is negative, however, negative is bad, so it's going to give us a frown. Obviously, I'm just doing the dots there as eyes. You don't need the dots in your actual question. The smile is the most important part of that. It's a handy way of remembering. And the same thing sort of applies for your cubic expression. So in your cubic expression, if your a is positive, so the number before your x cubed or the coefficient of x cubed, if that is positive, then your graph is going to finish on a smiley face, but there's going to be another turning point in that curve. So as you go up the powers of x, there'll be more turning points of your graph in general. So for my cubic expression, we're going to finish with a smiley face, but before that, there's going to be another turning point. So the shape of your graph in total is going to look like this. The same idea sort of applies for if your a is negative. So if your a is negative, you're going to start off, or you're going to finish with a frowny face. But before your frowny face happens, you're going to have another part of the curve and it's going to curve upwards like that. So you finish with the frowny face, but at the start of it, you've got another part of your curve. You need to be familiar with those three ideas because not only will it help you out with some questions, like visualizing what the question is asking you, it will also help you make sure that you got your answer correct at the very, very end. So if you had a cubic expression, let's say 2x cubed plus 7x squared plus 3x plus 2 is equal to 0, you know that seeing as the number in front of your x cubed is a positive, you know that you should end up with a graph like this one here. If you end up with anything different, then you know that you've gone wrong somewhere in your workings out beforehand. So just something to be aware of. Okay, so that's the shapes of your graphs. I'm going to jump to a recap on factors and roots now, and it might seem like a bit of a jump, but everything will be tied back together once we get onto our exam questions, so just bear with me. In your Junior Cert, you might have been asked to solve something like this, and you can use your quadratic formula and get straight down to our last lines here, and of course you have two answers. This is a quadratic, but in this case this is the workings out as if you had solved this equation using your guide number method and factorized your quadratic. The reason I'm using this is because of my last two lines here. It highlights the difference between the roots of your quadratic and the factors of your quadratic. So your answer right down at the very, very end, or your answers even, your two answers, your x is -3 and your x is 1. The 1 and the 3 are your roots of your equation. That's the name given to them. And we'll have a look at what they look like in your graph in a minute. But you need to be able to identify what your factors are as well. And the line just up above my last line here is going to help me out. As we can see from my second line, we've got two things being multiplied by each other to give me my top line here. So if I was to multiply out these brackets here, I would end up back at my first line. So that is the definition of factors of a quadratic. So your x minus 1 and your x plus 3 are your factors. And I'm just going to highlight those in my second last line here, and I'll put those in green. They are your factors. So just looking ahead to the exam questions that we're going to do, you need to be able to switch between, if you have a factor of a cubic polynomial or any polynomial, you need to be able to find the root from that. So you need to be able to interchange between my second last line here and my last line here, and you need to be really comfortable with which one are your roots and which one are your factors. In our next sort of jump on recapping, we're going to look at what the roots look like in graphs. So your roots, if we're thinking about graphs, it's where your graph crosses the x-axis. So for our linear graph, for a straight line, unless it is the x-axis itself, it can only cross the x-axis at one point. So I'm going to do my best straight line there, and my root of this equation here would be 2. So root would be x is equal to 2. And just to go one step further with that, that means that the point 2, 0 is on the line that I'm just after drawing. Your quadratic has nearly the same idea, except you're going to have two roots for most of your quadratic formulas, or for your quadratic equations. I will be doing a separate video on quadratic equations that have no real roots, so that do not cross the x-axis, but for this part of this video, we're just going to deal with quadratics that have 2 roots. So if I drew a quadratic, I'm going to draw a positive quadratic, and I'll try and make this as accurate as possible so that my graph actually lines up with the equation that I will have. So as I said, I'm going to do a positive quadratic. It's going to go down through -2, -6, up and around, and hopefully that'll go up through 3. So not my best curve, but I hope you can get the idea. My roots here, and let me just darken that green so you can see. Your roots here are x is equal to -2 and also x is equal to 3. Now if I was to try and go from my roots now to my factors, I would end up with x plus 2 is equal to 0. So that's just manipulating my first root here, and my second root would be x minus 3 is equal to 0. So your x plus 2 and your x minus 3 are your factors. So we've got roots, and now we've got factors. And don't worry, I will be writing these neater in my notes, and they will be in the description as well. Now, just a point, as with any factors, if you multiplied your x plus 2 and your x minus 3 together, you would get the quadratic that describes this curve here. So you would have it in the curve, you'd have it graphically, and you'd also have it algebraically, and you would be able to make comparisons between both. So for instance, this is a positive quadratic because we have a smiley face there. The number before your x squared should be a positive to reflect that. So what we've done so far is more or less Junior Cert stuff, your linear and your quadratic. What we'll be having a look at now is your cubic. So your cubic has one extra turning point than a quadratic. So I'm just going to do a brief one here. Something like that. And again, the point I'm trying to make is your roots are where that crosses the x-axis. So here, here, and let's just say that that crossed it at 6 just for argument's sake. So your roots would be x is equal to -4, x is equal to 1, and x is equal to 6. And we're going to need those facts to answer our exam questions, especially the fact that in a cubic you nearly always have 3 distinct roots, 3 different roots. Sometimes these numbers can be the same. So let's say you had x is equal to 1, x is equal to 1, and x is equal to 6. That's fine. You're going to have 3 numbers, but 2 of those are the same. We'll have a look in a minute or two about what that might look like if you have the same root twice. Let me just put that back to a -4 first of all though, so that it lines up with the graph I'm after doing here. Okay, a quick recap on everything I've said in the last 18 minutes. The roots of a polynomial are where it crosses the x-axis, and we must remember on the x-axis your y values are 0. So if we go back up to this example here, you'll notice that usually for a quadratic you could have had x squared plus 2x minus 3 is equal to y. Like that's a function of y. But if we are talking about the x-axis, and we are talking about the x-axis because that's where my roots are, then my y here is going to be 0. So if you have a quadratic equal to 0, they're basically asking you to find the roots of that. And you know that because if y is 0, they're talking about your x-axis. If you think about your coordinate plane, this point here is going to be 1, 0. This point here is going to be 2, 0. this point here is going to be 3, 0, and so on. You'll notice that the y part of all those points are 0, and that's going to continue on to the right, and it's also going to continue back towards your negative numbers as well. There are two ways of finding the roots, with a graph or algebraically, and today we're going to be concentrating on the algebra procedures. Again, just to recap, if you have a linear equation and if you want to find the root of that or where it crosses the x-axis, you let y is equal to 0 and you manipulate your equation to find out what x is. So you would have covered that in your Junior Cert. To find the root of a quadratic equation, you let y is equal to 0, and that's nearly always given to you in the question. And you can factorize, or you can use the quadratic formula, sometimes called your minus b formula, to help you out. And you'll get two values for x at the end. So again, that's your Junior Cert. And I'm not going to talk too much about the last step here just now. I'm going to loop back around to that because this here is your step up. This here is your step up to Leaving Cert Maths. So you might be given a question like this. This one came up in 2015. It was question 2, and it was a full 25 marks. They're asking you to solve that equation in front of you, and they say write any irrational solution in the form a plus b root c, where a, b, and c is an element of z. So let's just take a closer look at that for a minute. You'll notice that this is a cubic. You'll notice that it's a positive cubic, so it's going to have a smiley face at the end, and it's going to loop back around like that. So you know the shape of it already. But they're not worried about the shape. They haven't asked you to graph it. They've asked you to solve it. So if they ask you to solve that equation, they're asking you to find its roots. So you need to find out the 3 places where this equation here crosses your x-axis. You know that some of your answers are going to be irrational numbers because of what's said on your second line there. Some of your answers are going to look like a plus b root c, where a, b, and c are elements of z. That's just like your terms and conditions of your question. It means that a, b, and c have to be either positive or negative whole numbers. Your z there stands for your integers. So we must be ready for that. If we were to just stop and think where we had seen something like this before, we would have seen it when we were looking at square roots and indices, but we would have also seen it when we were looking at our quadratic formula. Quadratic formula. So in the back of our minds, we should be thinking, well, at some point, I may have to use the quadratic formula, in order to find some of my roots. So just something to be aware of. Before we do that, the first step that you're going to do in order to solve this equation here, green, is to try and find a value for x that works for that equation. So basically what you're going to be doing is substituting numbers into that equation until you find one that makes sense. This first step gets your question up and going, but it is a glorified trial and error part of the question. So I'm just going to write out my equation there again. X cubed minus 3x squared minus 9x plus 11 is equal to 0, just so you can see what I'm doing. And at this step, what we used to do in school is go straight to our calculator and start filling in numbers for that equation for the x's until I got one that was equal to 0. Now, there are clues in the equation as to what number will be easiest to get at the very, very start, and it lies in the 11 at the very, very end. So usually it'll be a factor of that number at the very, very end. So if you think about your factors of 11, Well, that's just going to be 1 and 11 because 11 is a prime number. So let's try the number 1 first, and I'll just put that up at the top here. 11 is 1 times 11. Let's see if 1 is will substitute into this equation perfectly. Now, you might be thinking, just before I do that, you might be thinking, well, how do I know when to stop? What if I try 1, 2, 3, 4, 5, 6? What if I try all the way up and I can't find a number that goes in? For your questions, you got to remember that this isn't a question to see whether you can just substitute a load of numbers in until you get to the right one. So with that in mind, your first number that you're putting into this equation, or to word that better, your first solution, it will be a small number. So either 1, 2, or 3, and maybe -1, -2, -3. So at most, you're going to be doing 6 calculations here, but as you get better at these questions, you'll be able to identify in your head, well, which ones won't work. You also have your calculator with you. You can use your calculator for this part of the question in order to help you out. So as I said, just back to what I was going to do, I was going to substitute in 1 and see if my answer made sense. So I was going to have 1 cubed minus 3 times 1 squared minus 9 times 1 plus 11 is equal to 0. And when I do that out, 1 cubed is 1, minus 3 times 1 is minus 3, minus 9 times 1 is minus 9, plus 11 is equal to 0. So let's see if my left hand side equals my right hand side. 1 minus 3 will give me minus 2. Minus 2 take away 9. So that's that bit. Minus 2 take away 9 is going to give me minus 11. So we're going to have minus 11 plus 11 is equal to 0. And as you can see, that makes sense. So from that, we can see that x is equal to 1 is a solution. So I'll just write that out. X is equal to 1 is a solution to, and we had x cubed minus 3x squared minus 9x minus 3x squared minus 9x plus 11 is equal to 0. Now comes the link back into the recap on factors and roots that I'm just after doing. So this right here, x is equal to 1, is a root of this thing over here. It's also a solution. It's solution and root in this case mean the same thing. So if x is equal to 1 is a root, then I know that if I take 1 away from both sides, so if I try and get 0 on one of my sides here, so I'm just going to take 1 away from both sides, I'm going to end up with x minus 1 is equal to 0. That's what I end up with. And my x minus 1 is a factor. So just like what we did up here, on this part here, we went from our root to our factor. I've done the exact same thing here, and this fact here at the bottom, this fact here is going to help me find my other 2 factors of this thing up here. So right now I have 1 factor, but remember, for a cubic I need 3, so 1 down, 2 to go. So if this is a factor of this thing up here, then if I divide x minus 1 into this thing up here, I should get out my other factor of this whole polynomial. So that's what I'm going to do. So I'm going to have x minus 1, and I'm going to divide that into x cubed And what did we say it was? Minus 3x squared minus 9x plus 11. So we're going to say x goes into x cubed, x squared times, and we multiply our x squared by all of this thing here. So x squared times x will give me x cubed. X squared times minus 1 will give me minus x squared. I take my new line away from my top line, so I'm going to end up with a minus, and that's going to be a plus, because if you're taking away a negative, it will turn into a plus sign. And what I end up with is x cubed minus x cubed is 0, minus 3x squared plus x squared is going to give me minus 2x squared, and I haven't used my minus 9x or my 11, so I'm going to bring those down. If you're unsure of what I'm doing here, or if you need a recap on that, I will put a link to Algebraic Division in the description below. But for now, my process here continues. Now I need to ask myself, how many times does x minus 1 go into my new equation here, my minus 2x squared minus 9x plus 11. So x, first of all, the x here goes into the minus 2x squared minus 2x times, so minus 2x, and then if we multiply that minus 2x by this thing here, we get minus 2x times x will give me minus 2x squared, minus 2x times minus 1 will give me plus 2x. Draw my line underneath, and I take my bottom line away from the line just up above it. So if I take minus 2x squared away, that's going to be a plus. And if I take plus 2x away from minus 9x, that's going to be a negative. So for this part here, minus 2x squared plus 2x squared is 0. So I'm just going to put a line through those so I know that I'm done with those. Minus 9x minus 2x will give me minus 11x. And I haven't used the plus 11 here, so I'm going to bring that down, plus 11. So for the last time now, I need to find out how many times x minus 1 goes into minus 11x plus 11. So x goes into minus 11x, minus 11 times, minus 11, and then I multiplied that minus 11 by my x minus 1, and hopefully, if I've done this correctly, I'll end up with the same thing as what I have here, the minus 11x plus 11. So let's see if that works out. Minus 11 times x will give me minus 11x. Minus 11 times minus 1 will give me plus 11. If I take my bottom line away from my top line, that's going to end up being a plus, that's going to end up being a negative. Minus 11x plus 11x will give me 0. Plus 11 minus 11 will give me 0. So after all that, we just need to make sure we know what we've actually found out. And in order to show you what you found out, I'm just going to do this sum here. Two goes into 6 3 times is what this whole thing is telling us here. And you would have done that in primary school. But we can also say that 2 multiplied by 3 will give me 6. So if we scale that up to what we have over here, we know that x minus 1 multiplied by this thing here will give me my original equation. So the x cubed minus 3x squared minus 9x plus 11. So we know that my factors of the x cubed minus 3x squared minus 9x plus 11 are x minus 1, this thing here, and x squared minus 2x minus 11. So in other words, x minus 1 times this will give me my original question. But if we go back to our original question, and I'll just take away the green here. They asked us to solve the equation x cubed minus 3x squared minus 9x plus 11 is equal to 0. And they asked us to write any rational solution in the form a plus b root c, where a, b, c is an element of z. Right now, what we have is this here, and we've got this. But we need to find out what our roots actually are. So we know from here that if these two are factors, well then x minus 1 is equal to 0 is going to be the x minus 1 part here is a factor. But if I wanted to find the root of that, if I added 1 to both sides, I'd have x is equal to 1. That's what we found out already from this side here. However, this side here on the right hand side, I need to break this down so that I can find my two other roots. So if you remember back to what we were talking about at the start, the fact that they've told us that our answer is going to look like a plus b root c, I know that I'm going to have to use my quadratic formula at some point. So this is that point. If I put this here, this quadratic, into the quadratic formula, I will get that my a is going to be the number before my x squared, that's going to be 1. My b is going to be the minus 2, the thing in front of the x, and my c is going to be the minus 11. So I'll just do the second line here, and then I'll jump straight to the answer, because I trust that you can use your calculator, I suppose. So my x is equal to minus b, so minus, my b was my minus 2 here, so let's put that in, minus 2, plus or minus the square root of minus 2 squared, minus 4, my a is the number in front of my x squared, which is 1, and my c is the number at the end, which is my minus 11. All over 2 times 1. When I complete that, I'm going to get that x is equal to 1 plus 2 root 3, and also x is equal to 1 minus 2 root 3. Remember, we're getting two answers because of this here, the plus and the minus together, so it's sort of like two equations in one. Let me take that away. So those right there are my other roots. They are my irrational roots, and we have written them in the form a plus b root c. So as far as we're concerned here, we have answered the question. So my three roots here are x is equal to 1, x is equal to 1 plus 2 root 3, and x is equal to 1 minus 2 root 3. Those are the 3 points on the x-axis where your graph will cross the x-axis. Looking to the marking scheme, there's a couple of different ways of doing that. The one that we did was this part here. So we found our first solution. We found that 1 goes into my equation. We then used the fact that x is equal to 1 is a solution to find the factor, which was x minus 1. We then divided x minus 1 into our original equation, and we got our other factor, the x squared minus 2x minus 11. And at the very, very end, if you jump down here, we got our solutions to x squared minus 2x minus 11 using our minus b formula, and our answers at the very, very end are 1 plus 2 root 3 and 1 minus 2 root 3. This here and this here are just two different methods, I suppose, of getting to the same answer, but I feel the way that we've done it up here, so not that one, not that one, this one here, logically builds up the blocks that you learned in Junior Cert to answer this question. Now, don't get me wrong, you're getting your full marks if you do it that way or that way, but I haven't covered that just yet. And this method makes more sense given the videos that I've done before, so that's the reason I picked this method here. I also think it's the most accessible. Okay. A question similar enough to that came up in 2017. And in 2017, your question was phrased a small bit differently. It said the function of f is such that fx is equal to 2x cubed plus 5x squared minus 4x minus 3, where x is an element of R, so your x's are real numbers. Show that x is equal to minus 3 is a root of f of x, and find the other two roots. So in this question here, they gave you the first root, and then that's going to make your job so much easier to find the other two. I'm not going to do this question out. We're going to jump straight to the marking scheme. And there was 15 marks for this question. So for your first part, showing that minus 3 was a root, all you have to do is substitute that into your first equation, the equation given in your question, and just make sure you get 0 at the end. If you got 0 at the end, you have proved that it is a factor. So just make sure that you tell the examiner that. That line there is quite important. Just let me know as an examiner that you've done what was asked of you and you want your marks. They then said, well, x plus 3 is a factor, so I'm going to divide it into my original equation. When they did that, they got, let me just move my blue mark, they got this here up on top. And it's up to you which way you want to factorize that. You could use your minus b formula, but you can also solve that using the guide number method as well. So as you can see just down here, and I suppose the line up above it as well is important, x plus 3 times 2x squared minus x minus 1, they're your factors. Then when you break the 2x squared minus x minus 1 down into its components, you get this and this. And when you let each one of those equal to 0 and find out what x is, at the very, very end, you get your x equal to minus 3, which you knew from the start because the question told you. And then you got your x equal to minus a half and your x is equal to 1. So again, you got your 3 roots. That question was easier than the one we've done previously because they gave you your first root at the very, very start, the minus 3. A similar question also came up in 2014, and I just made that a small bit bigger there. The questions that I wanted to concentrate on are the A part and the B part, because the only difference between this one and the one we've done before is you're not really dealing with numbers as such as we've done before. You now have k squared and k in there as well. So the last thing I want you to do is freak out when you see something like this, because you'll notice that the question asked is exactly what we were doing before. So to show that minus k is a root of f, all you're doing is substituting minus k in for x here, and if you get 0 as your answer when you simplify that, then you're good. If you want to try that yourself, I would advise you pausing the video now, because I'm going to go on to the marking scheme in 2 seconds. And here's the marking scheme for that. To show that minus k is a root of f, you want to find out what f of minus k is. In other words, you're substituting minus k in. And when you do that, and when you simplify it all out, you get your 0. So therefore, minus k is a root of f. If you don't get 0 here, it means you've either made a mistake in one of the previous steps, or minus k will just not be a factor. The second part of your question, the B part, just so you're aware of it, find it in terms of k the other two roots of f. So we're continuing on our procedure and we're taking k with us. It will be a small bit messier than the ones before, but your answer is going to look something like this. So you knew from the start that minus k was a root of f. So you knew that x plus k was going to be a factor of f of x. So just to on the side here, you knew that x was equal to minus k. That was your root. But if you add k to both sides, plus k, then x plus k is equal to 0. That part there, the x plus k, is going to be your factor. So still the same procedure, except now you're dealing with a k instead of just a number that you were used to. You then had to divide your x plus k, that factor, into your original equation and get your answer at the end. One or two things to point out here. In your original equation here, it mightn't be obvious to see, but you have an x cubed, you have an x, you don't have an x squared there. So in order to make this question flow as well as possible, you would need to rewrite that as x cubed plus 0x squared plus 1 minus k squared, let's put a squared there, x plus k. That there is very important because it'll help you keep your structure all the way down, and you'll see that that's what they've done here. Again, if you want to try this question and see if you get the same answers, that might be a very useful task to do, especially when we get to here and here. There's some things there that might trip you up along the way, so you got to be very careful with your algebraic division there. At the very end, they get their 0 at the end, so they know that this is one of their factors and this is one of their factors. And seeing as they need to break down the x squared minus kx plus 1, seeing as they need to break that down, we don't know what k is at the moment, so the best thing we can use is our quadratic formula, and that's exactly what they do. So in your quadratic formula now, your a is going to be 1, so that's the 1 in front of the x squared. Your b is going to be minus k, and your c is going to be 1. And you're filling that into your minus b formula, and that says that x equal to minus b plus or minus square root b squared minus 4ac all over 2a. When you plug those values in and when you simplify it, you will get your two other roots, which is that and that. And I know they look bulky and they look a bit more untidy than the questions we've done before, but seeing as you've done everything correct all the way down to there, that's you should be confident that you have your full marks in that question. That was a particularly sticky one. It took a lot of composure, I suppose, to answer that, and you did have to keep your head, especially when you saw the question and you saw that as well as the x's, the x cubed, and the x there and there, you had your k's to deal with as well. So yeah, that was a sticky enough question. 2014 it came up in. That's the last question I want to have a look at today, and there was the marking scheme. In a future video we will be looking more at the roots and how to know whether your roots are real or imaginary, so we'll be sort of touching into our complex numbers side of things. But for now I'm just going to leave you with the key points that we've done today, and again these will be in the description below. So the roots of your polynomial are where it crosses your x-axis. On the x-axis your y values are 0. Two ways of finding the roots, graphically or algebraically, and we concentrate on algebraically today. To find the root of a linear equation, you add y is equal to 0, find out what x is, that will give you a point where your graph crosses the x-axis. To find the root of a quadratic equation, let your y is equal to 0, and you can factorize using your guide number method or use a quadratic formula, find your values of x. And then what we had a look at today, to find the root of a cubic equation, you let your y is equal to 0, find one root by substitution, and that's like by trial and error as well, so it'll either be 1, 2 or 3, or -1, -2, or -3 that goes in. Again, use your calculator at that step, and the more practice you get at those, the quicker you'll become at getting your answers. Use that rule to find a factor of the cubic equation, so you're going from your roots to your factors, and then divide that factor into your original equation. And finally, with the answer that you get, you need to factorize that as well. So you may need to use your quadratic there. So may need quadratic formula. So as I said, that question there can be worth up to 25 marks, which is a huge chunk of marks. And if you are okay with everything that we had a look at here, so like your factors, your roots, your quadratic equations, your substitution, algebraic division, minus b formula, if you're okay with all of those from Junior Cert, then there's no reason that you can't score heavy marks on this part of the question. That's me for today. I will be doing another video, as I said, on finding out what the roots actually look like and something called the discriminant. So when I do that, I will put that in the description below as well. But for now, thanks for watching. Have a great day.